Hi everybody, today we're going to have a look at arithmetic series. It's going to be a quick one. So an arithmetic series adds the terms in a series for the first n terms. So given a general case, it would be the sum of the first n terms is the first term plus the second term plus the third term plus the first term plus all the intervening terms up to the second last term and the last term. Now we know that in arithmetic sequence, each term is made up with a specific formula. So the first term would just be a, the second term would be a plus d, the third term would have another d added on, and same with the fourth and the fifth up to the second last term, which would be a plus n take 2d, and the last term, which would be a plus n take 1d. Now keep this a plus n take 1d in the back of your mind because we're going to use it again later. Now, to get a formula for an arithmetic series where we're going to add all of these terms up, we have to do something a little bit clever. What we're going to do is we're going to take this series here and reverse it. Put the last term first and then the second last term all the way down to the first term. And then we're going to add them together. So if we added all of these with all of these, we're going to get twice the sum. So that's our first idea. And the second idea is that if we add this first one to the first one in the second series, we'll get 2a plus n take 1d being the first element, or the first term. And then if we take the second term of both of these series, it would have a plus d plus a plus n take 2d. Now, when we add those, it becomes this, which simplifies to that, and lo and behold, simplifies again to 2a plus n take 1d. Now, if we did that for the third, we would come up with 2a plus n take 1d, all the way down to the last, where we have a plus a is 2a plus n take 1d. So what we actually have is, if we add these two together, we end up with twice the sum, which is this. And by adding the individual terms, we'll get n lots of 2a plus n take 1d. Now, if we divide both sides by 2, we get back to the sum again, and we now know that this equation here will give us the sum of a arithmetic series, which is very clever, and we do this a few times for a few different problems. Now, there's another little clever thing based in here. 2a plus n take 1d is very like this last term definition. In fact, all we have to do is subtract an a from it. So if we have the last term and we add a to it and multiply it by n over 2, we will get the sum of the arithmetic series. Clever stuff. Let's have a look at an example. Find the sum of the first 5 terms of this arithmetic sequence. So the difference is 3. The first term is equal to 5, 8, 11, 14, 17. It's not hard to get the sequence and to add them up, and we get 55. That's not so hard. We could have done that before we go into all this new stuff. But if we wanted to learn the new stuff, the sum of the first 5 terms is equal to n on 2, 5 on 2, times by 2 times the first term. Well, the first term was 5, 2 times 5, plus n take 1, n was 5, 5 take 1 is 4, times 3. And then we'll get 5 on 2 multiplied by 22, which if we use distributive law, we'll find out is 55, or if we just used our calculator, that would have been easy. Now, I said earlier that we could work out the same answer by knowing the last term in our sequence. So we know the fifth term, which is the last term that we're looking for. So if we take this equation here, the fifth term times by the first term plus the last term. So the fifth term is, the first term is 5. We're looking for the last term, which in this case is the fifth term, which is 5, which is 17. Add them together, times by 2.5, and again we get 55. Any which way will work depending on what information is given to us. But what about if someone threw a curveball and gave us a problem that wasn't so straightforward? So if we had the sum of the first n terms of an AP is given by the sum of the terms is equal to 7n take n squared. Now that's not like any formula that we're used to. Can we use that to find the first term and the common difference? Well, yes, we can. Because we know some features of a series. The first feature we know is that the first term will be T1, even in a series. And if we find the second term, we can use that to find the common difference. So let's do it here. S1 equals T1, like I said earlier. So for n equals 1, S1 equals 7 times 1, take 1 squared, just that formula there, which equals 6. So the sum of terms up to the first term is 1, which gives us T1. So we have our first term. Brilliant. Looking at our second term. Sorry, that shouldn't be S1, that should be S2. Let's fix it up. S2 equals T1 plus T2, e.g. if n was 2. So S2 would equal 7 times 2, take 2 squared, which will give us 10. Now, I've done it again. We know that the sum of the first two terms is just equal to T1 plus T2. We know that the sum's equal to 10. We know that T1's equal to 6. Therefore, T2 must be equal to 4. 4 plus 6 will give us 10. Now, once we know that, we can subtract the two values. So, if we know that the first term is 6, and I've done this in the wrong order. Don't know how much I've done wrong in this one. So, T2 is 4. T1 is 6. If we subtract them, we'll find the common difference. 4 take 6 gives us -2, as expected. And there are some simple problems done for arithmetic series. I hope that helps with completing the exercise. Thank you, everyone.